At Spectraseis, we stress full elastic wave equation processing methodology under the assumption that if we program into the computer the most complete description of the physics involved in the field experiment, then we have to do less interaction with the data, and we make fewer assumptions about what may or may not have been happening in the field experiment that we're trying to reverse in the computer.
We care about microseismic data because it's really the only chance we have to see what our frac stimulations of our wells are doing in the subsurface.
The key aspects of Spectraseis solution is both completeness in the field and completeness in the processing shop. So we record the full wave field and we use the full wave field during processing.
Microseismic data impacts the economics of our reservoir by helping us define the optimal well spacing and frac spacing as we develop these continuous unconventional reservoirs.
Surveys that only acquire data with single component phones are just missing an obvious opportunity. Because there's 10 times more shear wave energy emitted during a fracture event, the capturing of that energy just makes our job as geophysicists a lot easier.
Microseismic monitoring in particular started out as a borehole-only technology, and what we found is that the geometries and the aperture of a recording arrays are pretty limited in the borehole.
The most important aspect of reservoir modeling and predicting production from a reservoir engineering standpoint is characterizing the fracture network that we've stimulated in the reservoir. All fracture networks don't look the same. Different fracture mechanisms actually lead to different networks that will respond to flow differently over time. So if we can fully characterize not just where something happened, but how that fracture broke, we can incorporate that knowledge into the reservoir model that will have drastic repercussions into how that well will perform over time. So the future of microseismic analysis, I think, is going to be stressing the completeness and the thoroughness of the processing to better mimic the physics that are going on in the field.